Okay, in this video what we're going to do is continue on with our review of our midterm exam, and we're going to begin with question number 5. First of all, number 5 is asking for the range, and the range is the lowest y and the highest y value of the function. So best thing to do for a range is to graph the function, take a look at it, and see where the lowest y and the highest y are. In this case, the floor of this graph is at 3, and I drew that line just to emphasize that. And then a square root function, as we know, continues to rise without bounds, so it would be infinity. Okay, our next question is asking us to find the limit. Keep in mind, limit is intended height, not actual height. And the notation here is real important to remember. When you have a limit with a directional sign after the number, then you are going to only take a left-handed limit or a right-handed limit. And so in this case, it's approaching -1 from the left. And what you're looking for is the intended height, not the actual height. And we know it doesn't exist at -1, but its intended height is -2. And in like manner, as you're taking the limit as x approaches -1 from the right, the intended height of the graph at this point is -7. And bear in mind that if it was asking for the limit as x approaches -1 without the directionals, the answer would be does not exist, because in order for it to exist, the right-hand limit and the left-hand limit must be the same number. And that's just not the case in this question. Number 12, I'll like it when it allows us to approximate the real zeros, because then we can just use our second calc key on our graphing calculator. But this one turned out even better, because when I put it into the graphing calculator, there were no zeros or x-intercepts. So the answer would be none. 0 zeros. All right, 13. Determine whether it's a function. This is an oldie, kind of goes back to Algebra 1, but at any rate, a function is a set of ordered pairs in which the x value does not repeat itself. And when you have a graph, the vertical line test is the best means of determining that, because if it strikes the graph more than once, its x value repeated itself. So you can see just using the y-axis that it failed the vertical line test. So this is not a function. And next question would be 15. Now 15 doesn't really tell us to use algebra or graphs, so we can use just a little bit of both here. And it's pretty easy to see that I've got a 0 at 0. And another one here over at 4. But this one is kind of non-readable, so let's just go ahead and use our synthetic division. First thing I can do, however, is factor out an x, which leaves me with 3x squared minus 7x minus 20. And I'm sure this could be factored, but let's just use the method synthetic division. It appears that positive 4 is a 0, so I'm going to run positive 4 through this, drop down the initial number, and start multiplying. You get 12. Adding this result, you get 5. 4 times 5 is 20. And this confirms that it is a factor, because the factor theorem says that if the remainder is 0, then you have discovered a 0 of the function. The 3 and the 5 can be interpreted as 3x plus 5. And that's going to allow us to find the third 0 here. So x is equal to -5/3. All right, so let's sum this up. Our 3 zeros, whoops, it didn't look right. Our 3 zeros are at x equals 0, x equals 4. You have to excuse me, I'm not used to this pen tablet, and -5/3. All right, number 25, it says to solve it graphically. With our graphing calculator, I've already put it in, And what I've done is, you look here, is I've put the absolute value of 4x minus 8 in, and I've also put the number 2 in, because we're looking for where these two equations equal each other. And then as you look at the graph, you can see that they equal each other at these 2 points of intersection. Well, one way to find those 2 points of intersection, as you can see from my graph, is second calc 5. And I want to, since I have 2 points of intersection, I'm going to pull this graph a little bit over and hit enter once, twice, 3 times. It gives me the left intersection, which is at 1.5. To find the second, we're going to go back to second calc 5. And this time, to find the one on the right, I'm going to have to pull this cursor over so that the calculator understands which one I'm looking for. And once it's over here close to that line, we can just push enter once, twice, and 3 times, and that gives us 2.5. So graphically we found that it is equal to 1.5 and 2.5. By my table of values, I can see that they both equal 2 at 1.5 and 2.5, so that also confirms that. Algebraically, this could have been solved by setting a -2 on the left-hand side and solving both of those equations as a result. So let's just write this in. X is equal to 1.5 and 2.5. All right, the next question is to find the local max and min. Well, local means there could be more than one, and in this case there are 2 local minimums. And unfortunately, this is not really easy to read because they're not going through a readable point, but we'll do the best we can. The minimum values occur at, let's take a look at this one. It's not quite -8, so let's just say it's -7.8. And notice I'm listing the actual minimum, not the x value where it occurs, but the actual height or the y value. We have another minimum at looks like close to 3. I'm going to say 2.8 on that one. And then we have a local max, and this one's a little bit easier to read, at 8, close to 8. And that's how you'd answer these types of questions. If it said absolute, you'd want just the highest and the lowest of the graph. All right, and number 28, how many complex and real zeros does the function have? I really didn't have to use the graphing calculator to figure out how many complex, because the fundamental theorem of algebra says that whatever the degree of the equation is, then that's going to be the number of complex zeros. So there's 5 complex zeros, but only one of them is real, because the real zeros are indicated, are going to be found by looking for the x-intercepts, and there's only one. So there's 1 real and 5 complex. That means there's 4 imaginary. Didn't mean to do that. What did I do? Let's pause. Okay, hit the wrong button there, but I'm back. Got it back up and running. All right, and the last question is match the graph with its polynomial function. And I just want to take a look at, the answer is obviously letter D, but let's see why. We have a graph that has opposite end behavior, and the only polynomial functions with opposite end behavior are odd degree equations. And that would disqualify letter B because it is even. Now, the other thing we'll notice is that it's rising to the left and falling to the right. And just like a line, which is an odd degree equation, by the way, it is a negative slope here. So we're going to have a negative leading coefficient, which disqualifies letter C. And finally, how do we determine whether it's A or D? Well, this is one that we haven't really taken a good look at a lot. So this would be a great time to do that. If you ran a 0 through this to find the y-intercept, you would notice it would be at -12 on letter A. If you did so with letter D, you'd see it's a +12. Well, there's the y-intercept. It's definitely not a -12, so it would have to be letter D. And that concludes this video, and I'll continue to make another video on the rest of the questions, but I'm going to stop here for right now. Maybe. We're trying. Let's diminish that and